All right, welcome you guys. Let's go ahead and finish off 4.5. So in this part 2, basically I'm just going to be graphing a bunch of graphs. I think I have 5 graphs that I'm going to be graphing for you. They take a while because there's so many parts, but I wanted to make sure I gave you a bunch of examples. Okay. All right. So we're going to start by finding the domain, okay, which basically means setting the denominator equal to 0 and solving. And then we'll determine which of those zeros are wholes or vertical asymptotes. Okay. Then we'll find the x and the y-intercepts. For x-intercepts, we let y be 0. And then for y-intercepts, we let x be 0. Now, it turns out we only need to find the zeros of the numerator for x-intercepts. And I'll talk about that a couple times. I'll show you that only the top matters. And then hopefully we'll work our way into just setting the numerator equal to 0. Then we'll find out whether or not it has a horizontal or a slant, and we'll remind you of those rules, okay? And then we'll find out if it crosses the horizontal or the slant. And then we'll just plot some extra points to kind of clean it up and make sure that we're in the right regions on the graph. Okay, so let's kind of go through this. All right, so number 1. Let me see if I can shrink just the graph. Okay, I'm going to move it to get it over there a little bit more. There we go. Okay. So we want to find the domain, right? So we need to start by factoring the denominator. Okay. So we're going to take 3x squared plus 7x minus 6. And we're going to see if it factors. Okay. So we're going to use the AC method for factoring here. So we're looking for factors of a times c is -18. So things that multiply to make -18 that add up to +7. Well, that would be 9 times -2. Okay. So we're going to go ahead and write this as 3x squared plus 9x minus 2x minus 6. So remember, we just used those two numbers to re-express the 7x, to rewrite the middle. Everything else is the same. All right, so we're going to slice it down the middle and use factoring by grouping. So we're going to take out a 3x. And we're going to have to take out a -2. Remember, whatever this sign is, you have to keep it. So that is going to change the sign and make this a +3, which is good because we want these to match. That's going to be one of our factors. And then the leftovers is the other factor. Okay, so we come up here to our original equation. And it can be rewritten. This is equivalent to it in the following way. Now, nothing cancels with the numerator, right? Nothing cancels. So that means that we're not going to have any wholes, right? Nothing cancels, so there are no wholes. That means that all of these zeros of the denominator, right? So we're going to set these equal to 0, each one of them. That these zeros must be vertical asymptotes. Okay, so x equals -3, and we're going to move the 2 over, and then we'll divide by 3. So x equals 2/3. These are going to be vertical asymptotes of the function. I'm going to go ahead and graph those right now. So we'll make sure they're dotted since they are vertical asymptotes. They're not part of the graph. Anything that's dashed is not part of the graph. And we'll say that 2/3 is about right here. Okay. Make this one a little bit, oops. I thought something was strange about that. But I can't even see it. There we go. You know what? Let me just undo. There we go. Let's try this again. Delayed reaction on my computer's end there. There we go. We'll call that 2/3. Okay. All right. Okay, so we got that part done. So now we're going to go in and we're going to get the x and the y-intercepts, right? So remember that for x-intercepts, we let y be 0. And we said that it's technically only the numerator that we set equal to 0. But let's just kind of see why it's only the numerator. Because normally when we're finding x-intercepts, we just let y be 0. Okay. So we would have to multiply by the denominator to both sides to get rid of the fractions here. So we'd have to do it here, and then we'd have to go and do it on the other side also. But remember, 0 times anything is 0. So essentially, it just amounts to us setting the top equal to 0. Okay. Plus, another way to think of it is, okay, I have some sort of fraction and it equals 0. Well, the only way a fraction could equal 0 is if the top equals 0 and the bottom does not. Okay, because this is technically undefined. That doesn't equal 0. So we want to make sure that the top is 0. That's enough to make the entire fraction go to 0. Okay. All right, so we're going to go ahead and subtract 3 over, so it'll be a -3. And then we'll divide by 2. So we get x equals -3/2. Okay, in other words, -1.5, right? Okay, so that means that we have at -3/2, comma 0, our x-intercept. So -1.5, that'd be like right here. All right, now let's go ahead and go in and get the y-intercepts. So for the y-intercepts, we're going to let x be 0. This is opposites. Now, I personally like to let x be 0 in the original and not the factored, because then it just amounts to putting these last numbers on top of each other. Let me just kind of show you that. So if we substitute a 0 in for every single x, it'll look like this. Well, any term with a 0 in it is going to go away. So it looks like we just have 3 over -6. So how easy is that? In the future, we can just look at the last numbers. And when you reduce that, you're going to get -1/2. So 0, comma -1/2 is going to be our y-intercept. So like right there. Okay. Let me go ahead and just copy this graph that we have so far. Okay. Let me take a screenshot of it. I'm going to bring this onto the next page. Then I'm going to grab our factored version of the original. Okay. That on the next slide. All right. So we're at the point where we need to plot points now. Oh no, I'm sorry. We're at the point where we need to find whether it has a horizontal or vertical asymptote, right? Okay. So that's the question we need to ask ourselves. Horizontal. First time around, let me write it out. Horizontal or slant? Okay. All right, so remember that for the horizontal, we just compare the highest degrees, right? Well, it's a degree 1 over a degree 2. So this would be the case where the denominator is larger, right? Big bottom. Anytime that the denominator is larger, you have big bottom, it's always going to be 0. We talked about a fraction with a really big bottom. We said, hey, try to think about a fraction that goes to infinity. And that's really the whole thing. That's pretty much 0. Okay. All right. So y equals 0 is going to be where our horizontal asymptote is. Okay. So here's our x equals -3. Here's our x equals 2/3. And here's our y equals 0 in the graph. So now we are ready to start plotting some points here. So here's how I think about it. I try to get points on each side of all the asymptotes. So I'm probably going to substitute in -4 so I can figure out what's going on to the left of this vertical asymptote right here. Okay. So we're going to plot points. Okay, so we're going to set, we're going to put -4 inside of our t-chart. All right, now I also want to pick somebody. I have to pick somebody in the middle because I'm not really sure if this goes like this or if it goes like this. I have to find out. So I'm thinking if I substitute in like -2, I will find out whether or not this comes back down or if this goes up. So I want to put -2 in my t-chart. Then I have to pick something to the right of x equals 2/3 so I can see where I am over here. So I'm just going to pick 1. Now, normally we would have to set the original equation equal to 0 to find, basically you set the original equation equal to your asymptote to see if it crosses it. But we already did that math. We already set the original equation equal to 0. And we only got one answer. So what that means is we're only going to cross the horizontal asymptote once. So keep that in mind. It's not like I'm going to cross it again. So that's why I said right here, it has to go either back down or it has to go up and stay up. It can't be like something like that, because then I'm crossing again. I'm really only allowed to cross once. And that's also why just 1 point will be good enough over here. Because if I have 1 point and let's say it's positive, well, then I know I have to look like this. There's no way that I could be like, and all of a sudden head down at the asymptote, because then that's me crossing again. So instead of going down, I have to go up. Okay. So keep in mind that we only have one time where we cross the asymptote. So let's go ahead and substitute these points into our equation. Now, I find it easiest to substitute them into this one because I don't have to type exponents in my calculator. But honestly, whatever works for you, they're both going to get you the answer, right? Okay, so I'm going to substitute it into 2x plus 3. So 2 times -4. Well, that's funky looking. It might throw some people off. So let me use parentheses so it doesn't throw you off. 2 times -4 plus 3. And then in the denominator, I'm just going to substitute it in right here. So it's going to be -4 plus 3. You could probably do this by hand faster, but I just know most of my students would substitute it into the calculator because they don't trust themselves. I'm worse with the calculator, you guys have probably noticed. Okay, so I substituted -4 in for all the x's. Let's hit equals. I got -5/14. Okay, now I want to substitute 2 in. So I'm just going to go in, and wherever I had a -4, I'm going to put a -2. Put 2 there. Let me go up. Oops. Okay, then let's go ahead and hit equals. I'm getting 1/8. And then we're going to go ahead and substitute 1 in. So the arrow 1. 1. All right. Clean up some of these stray marks. Okay. Now this is 1 and 1/4, by the way. So I'm just going to graph these points. So I'm going to graph the point -4 and then -5/14. Now that's not even 1, right? In fact, that's not even half. 7/14 would be halfway. So I'm going to be a little bit less than halfway, like maybe right here. So that's going to be this point. Just put it into a calculator to get the decimal. So what does that tell me? Well, I know I'm not allowed to like go up because I'd be crossing the horizontal asymptote. So that tells me that I need to, as I approach the vertical asymptote, head downward. And remember, you head towards the horizontal asymptotes out at negative infinity. So I'm getting closer and closer to this horizontal asymptote of 0 as I head off to negative infinity. All right, we got the point -2, 1/8. So at x equals -2, I'm positive 1/8. So really small. 8/8 is 1. So 1/8 would be really tiny. So that tells me enough. That tells me that we already knew this much. But now we also know that we're going to go up in the middle. Okay, I can't go back down because I crossed the asymptote again. And then our last point is 1 and 1 1/4. Okay, so 1 and 1 1/4. So like right there. So that tells me that I am above the horizontal asymptote. I'm going to approach it as I go out to infinity. Oops, I actually touched the vertical asymptote and I didn't mean to. There we go. Now I know this looked like a lot of faking, huh? You're like, man, you were just kind of faking a lot of that. But when we go and we put these in, I think you're going to be surprised with how good they actually look. Okay, so let me go ahead and put in the original function. I always put in the original in case I made some mistakes with my factoring along the way. Okay, so I'm going to go ahead and look at this. I mean, this in comparison to, let me hide that. Move that over. That in comparison to what we got. I mean, look how good that is, despite all of my faking. Okay, so let's get down to the nitty gritty. -3 is where a vertical asymptote is. That's what we have. 2/3 is where we had the other one at. That looks good. Okay. We crossed at -1.5, right? And that looks like that's -1.5. And then we crossed at, what is that? -0.5? I can't remember. I'm trying to go off memory here. I think it was on the other slide, but it looks good. Okay, moral of the story, it looks good, despite all of our faking. All right, let's try another. Now these just take a while to feel the rhythm. I mean, that's the goal in math, is to do enough examples until you get the rhythm down. These, because there's so much involved, it takes a while to get the rhythm. So if you're like going through like 5 of them and you're still kind of like, what's going on? That makes sense. They're really long. So I think it would take like 10 before you would start to feel like you get what you need to do. Okay, so let's go ahead and start by getting our domain, which means we need to factor. We're actually going to factor both the top and the bottom. Hopefully the top is quick for you. It's a difference of squares. So x plus 1, x minus 1. That one shouldn't be the one that gives us trouble. It should be this other one, right? I mean, it's not like this one's going to give us a ton of trouble either. We're looking for things that multiply to make -6 and add to make 1. All right, let me think. Every time I say this one won't be hard, that's when I mess up. So I have to really check myself. All right, 3 times -2 is -6. 3 plus -2 is 1. That looks perfect. So we can go right away into the parentheses. I don't have to use the AC because the leading coefficient's 1, right? Okay, so I'm going to put those. This is an equivalent version of our function. Now, again, nothing cancels with the numerator. So that implies that we are not going to have any holes. That means that everything in the denominator that we set equal to 0, so the x plus 3 that we set equal to 0, and the x minus 2, these will all be vertical asymptotes. Okay, so I'm going to go ahead and go in, put some vertical asymptotes at -3 and +2. All right, great. Okay, so after we get our domain, we go in and we get our x and y intercepts. So let's go ahead and do that. So we said for x-intercepts, we let y be 0, right? So that means this part's going to be 0. And we said it's enough to just set the top equal to 0. Okay? You don't have to set the denominator equal to 0 because a fraction will be 0 when the top is 0. And there's so many ways you could have done this. You could have set the factored version equal to 0, whatever. Okay. I'm going to move the 1 over. And then I'm going to go ahead and square root. And I'm not going to forget my plus or minus. So x equals plus or minus 1, which is kind of obvious from the factored versions, right? So that means that at 1, 0 and at -1, 0. All right. Let's put those in our graph. All right. Okay, so let's go in and get the y-intercepts. So for the y-intercept, we let x be 0. And I told you guys I like to do it in the original, not the factored. So I'm going to go ahead and substitute 0 into that. And that's going to annihilate all of these terms and just leave us with the -1 over -6. I'm going to write it out for our notes' sakes. Okay, so 0 squared minus 1, 0 squared plus 0 minus 6. And I probably won't on the next one write it out. I mean, it's kind of new and fresh, so I just want to make sure I'm not confusing anybody. All right, so 0, 1, 6 is where. Now 6, 6 would be 1, so 1, 6 might be like right there. Okay, so we got our y-intercept. Now we need to ask ourselves whether or not we have a horizontal or a slant, right? That's got to be the question. Horizontal or slant asymptote. Okay. So I'm noticing the degrees. That's what we have to look at. We have the same degree. So the degrees are equal, right? So that implies that we're going to make a fraction out of the front numbers. So we're going to make a fraction out of that. So 1 over 1. So that means it's just going to be y equals 1 for our horizontal asymptote. All right, so y equals 1. Oh my, undo. There we go. Oh, undo again. Guess I need to be all the way over here. There we go. Fine. Sorry, you guys. I have all these stray marks on here. Okay. All right. So I'm going to go ahead and get a picture of this. Let's go to a new screen for the plotting points and the seeing if it crosses the horizontal asymptote. And then I'm also going to grab the original. So we're still on example 2. Let's grab this one. All right. So we have to see if we cross the asymptote, right? So we're going to set. We didn't have to do this on the, well, because we'd already done it. That's why we didn't do it on the last one. But I want to make this really clear. To see if the graph crosses the horizontal asymptote, or set the simplified equation equal to the asymptote. In this case, we didn't have to simplify anything. We didn't have to cross anything out. So we can just set the original equal to the asymptote. So we're going to take the original equation. And we said that the horizontal asymptote was at y=1, right? All right, so we're going to go ahead and multiply both sides by the denominator to make it cancel here. Now, if you see a term that's on both sides, you can just cross it off, because what you're really going to do is you're just going to subtract that term away. So if you ever see a term that's on both sides, you can just cross it off. It's going to be our shortcut. And it looks like we are going to cross. So we're going to cross at 5, 1. So I'm going to go ahead and put a dot right here on the graph to show that we crossed that horizontal asymptote. So now we're at the plot points part, right? So we have to be strategic when we pick these points that we're going to plot. All right, let's go consult the graph to see what points we should substitute in. Okay, I'm convinced of the middle. I know that it's not like it's going to go like this and come back up, because I would cross the asymptote again, and we only got one point where it crosses. So I'm pretty convinced that it's going to look something like this. Okay. Now, what I'm not convinced of is what's going on over here. I don't know if I'm above it or below it. So I'd love to pick a point over in that region. So maybe -4. And then over here, I have no idea really what's going on, if I'm above and I cross, you know, or if I'm below and I cross. I have no idea. So I'm going to pick 3 and substitute 3 in. Okay. All right. And you guys know that I like to substitute it into the simplified version, because usually I do it by hand and it's so much easier by hand. But I'm going to go to the calculator just because I know that's what my students would do. Okay, so we're going to go ahead and put -4 in everywhere where we see an x. So -4 + 1. And then -4 - 1 divided by. Oh, you know what? Another thing that my students would probably do. Sorry. They would have hit this button. Oh, no. Oh, my. Okay, let's start this over again. All right. Let me try this again. There we go. Okay, so we got -4 + 1 and -4 - 1. And this is going to be on top of -4 + 3. See, I feel like I could have answered this already doing it by hand. I have to model the calculator usage. Okay, I think we're good. Let's see, we got 5 halves. All right, so 5 halves would just be 2.5. So we're looking at -4, 2.5. So -4, 2.5. There we go. Okay, so I know that it has to be, it looks like this. If my pen will write. There we go. Remember, we got to head towards the asymptote as we head out to -infinity, and we have to head towards infinity. We can't go down because we'll cross the asymptote. All right, let's substitute in 3. I'm going to do 3 by hand just to show you. I find the calculator tougher for myself. So this is going to be 4 times 2 over 6 times 1, 8, 6. Take half of them both, 4/3. Oops. So 1 1/3. Okay. So it looks like at 3, we're at 1 1/3, or 3.33. Okay, so 3, 1.33. There we go. Okay, so we know we're up here. We're going to come down and we're going to cross now. The thing is you have to remember that you have this horizontal asymptote, right, at y=1, that you're going to head towards it. So even though this is going to, you know, come down and hit this and then cross, it has to still come back up and head towards the asymptote. So let me just try to draw it. It's kind of hard. Oh my goodness. It's kind of hard with a stylus. It's so much easier with like a pen or a pencil, but let me see what I can do. So here we go. I just didn't make the concavity correct here, I'm sure. Really hard with this. I'm already not liking it. There we go. Okay. All right, so let's see if I can fit that on this screen. Okay. So just make sure that you don't do something like just head down forever. You do have to remember that you have to come back up here. Come back up here and head towards this horizontal asymptote. Okay, so let's go see what that one looks like. How well did we do on this one, right? Okay. Let's delete this guy out and let's put in what we have. So remember, put in the original just in case you made a factoring mistake along the way. All right, let's go see what this looks like, you guys. Okay, so let me put in the asymptotes just so we can see, but I do see 5, 1 on here, right? Let me put in the asymptotes of x equals -3, x equals 2, and y equals 1. Okay, now it's hard to see that we crossed the asymptote. So what I'm going to do is let me just stretch the y-axis a little bit. There it is. Now it appears. So we came down, we cross, and then we're going to head back. If we go out this way, you can see we're going to head back towards that asymptote. So that was kind of tricky moment, that behavior. We did have this funky looking downwards parabola. It's not symmetric. We had that in our graph, kind of this wonky, not symmetric parabola. So this looks great. I'm telling you, for us doing a lot of faking, not too bad. All right, that was example 2. All right, example 3. So we're going to go in and we're going to get that done manually. So we have to factor. So we are looking for factors of -2. So things that multiply to make -2, that add up to make -1. -2 times 1 will do it. Okay, so the original function, x minus 2 over x minus 2, x plus 1. We do have something that cancels this time, right? That means that that is going to be the whole, and this other term will be the vertical asymptote, okay? So when we set these equal to 0 to get our domain, we get +2. And then when we set this one equal to 0, we get -1. So we have a whole at 2 comma something, and we have a vertical asymptote at x equals -1. So let me put the vertical asymptote into the graph while we're here. And then for the whole, we're going to have to take this -2, and we're going to have to plug it into the simplified version. We don't want to plug it into the original or substitute it into the original because it'll be undefined. So we're going to take that and we're going to substitute that 2 in. Let me see if I can find a way to go around stuff. Oh no, that was not good. I went off the grid though. There we go. Okay, so basically, let's see, it's going to be 1 over 2 plus 1, which means it's going to be 1/3. So at 2 comma a third, we're going to have a hole. Okay, so now we're going to go ahead and get those intercepts, right? The x and the y-intercepts. So for the x-intercepts, we let y be 0. And we're just going to set, now we're going to do this with the simplified version, okay? So we're going to make sure you use the simplified version. Now on this one, it can never, like we said, you really only have to set the tops equal to 0, you guys. I didn't need to put that x plus 1, but I just wanted to make sure everybody knew they were setting the simplified version equal to 0. If we put an x plus 1 in here, that cancels, and an x plus 1 multiplied by 0 is still 0. So you get 0 equals 1. And that really was just setting the top equal to 0, right? Well, that's going to be no solution. So what that means is there's no x-intercepts. All right. Okay, so then let's go in and get our y-intercepts. So for our y-intercepts, we let x be 0. Okay. So we're going to go ahead and substitute 0 in. And again, I'm going to use the simplified version. We end up with 1. So 0 comma 1 is going to be our y-intercept. Okay. All right, let's see where we're at. We're at the point where we have to determine whether or not we have a horizontal or a slant asymptote, right? So let's go check out those degrees. So if we look at the degrees, it's big bottom again, huh? I think our example 1 was big bottom. If the bottom of a fraction is big, it really just keeps getting bigger and bigger, then you're heading towards 0. So y equals 0 is going to be our horizontal asymptote. There we go. Okay. Oops, I just called that y because I had y on the brain. This should be x equals -1. All right. So now we just need to see, do we cross the asymptote, right? We cross the horizontal asymptote, question mark. So we are going to set the equation, the simplified version, equal to the asymptote of 0. Now we already did this math, right? Over here, you guys, and we got no solution, right? So remember that no solution means that it won't cross, doesn't cross the horizontal asymptote. So I kind of already know a lot then. I know that the graph is going to look like this. As far as on the right-hand side, okay? All right, but now let's go ahead and figure out what's going on over in this region, right? So maybe we could substitute in a -2. So this will be us plotting points. In this case, we don't need to plot points, just one point will do it. And we're always going to substitute it into the simplified version because it's simpler, right? The math is simpler here. And these aren't exactly equal. I should have put an approximately sign, right? They only differ at the point where there's a hole. This right here no longer has a hole, so it would just go right on through, not have one. The original did have a hole, and so it would be open here. But elsewhere they match. So let's use that simplified version to do the math for us. Look how easy it'll be, right? We're going to substitute -2 into this. That'll be fast. All right. So at -2, we're at -1, and we're not allowed to cross the horizontal asymptote. Then we have to stay down here where the negative values are. We cannot go up above the x-axis. All right. Now again, the on GeoGebra, it's not going to show you the hole. You kind of have to just know that the hole is there. Let's see what this looks like. Okay. All right, so we got x minus 2 divided by x to the second minus x minus 2. It did show it. So sometimes it does, sometimes it doesn't. So we said x equals -1 was where our vertical asymptote was. I'm just gonna let that go. That looks so good when we compare it side by side with what we had, right? And notice that our hole went away at 2 whatever, but if we click on it, it tells you removable discontinuity when the hole comes back. And we'll do that if you click anywhere else on the graph, guys. You have to click right at the hole. Okay, so this looks great. Wow. Okay. Just back over. Hopefully you're starting to get a little bit of the pieces, and maybe at least you know the steps, that part of the rhythm you have. So we're going to go in here, get our domain. So we're going to go ahead and factor that. Let's factor a 2 out, make it easy on ourselves. And then we don't have to use the AC method. We can just say, okay, what are factors of +4 that add up to -4? -2 times -2 is +4, but -2 plus -2 is -4. So it looks like we're going to get an x minus 2 and another x minus 2, or if you like, x minus 2 squared, right? So that's going to be the top. There we go. Okay. So nothing cancels. So that means that we have no holes. That means that when we set that denominator equal to 0, okay, so when we set x minus 3 equal to 0, that what we found is a vertical asymptote. There we go. Okay, so let's get the x and y-intercepts. So to get the x-intercepts, we set the numerator equal to 0. We let y be 0, but we only have to do it to the numerator, okay? Now remember the numerator, we already factored it, so let's just set this version of the numerator equal to 0. I think that one will be easier. I mean, clearly you could probably see that it's 2, but let's go through the actual math. So we get 0. And you can really see that it would have to be 2 here, right? Because if you plug a 2 in, 2 minus 2 is 0, right? But if you want to keep going with the math, square root. And now it's probably much easier to see. You'd have to add the 2 over to make it positive, right? That 2 over to the other side. Okay, so 2, 0 is going to be our x-intercept. Let's go in and get our y-intercept. So in other words, let's let x be 0. And we're going to do that in the original. It's so much easier in the original now. Remember, if there's a 0 plugged in, this is gone, this is gone, this is gone. It's just going to be 8 over -3. So 0, -8/3, which would just be 0, -2 2/3, or -2.67. ish. Okay. All right. So 0, comma, negative 2 and 2/3. So let's say this is 2, you guys. And let's say that this is 3. So maybe like right there. Okay. All right. So now we have to say horizontal or slant. Well, let's look at the degrees. Since the top is 1 degree higher, hopefully you remember and kind of pausing, hoping that you will. There is a slant asymptote or oblique. Remember to find that, divide and ignore the remainder, right? Divide and ignore. Okay. Now we can actually use synthetic division since the divisor has a leading coefficient of 1 and an exponent of 1. So remember, take the opposite sign here because you set it equal to 0. It's going to be a positive 3 that's going to go in the box. And we're looking over here, right, to get the coefficients. So 2, negative 8, and 8. All the exponents were there, so we didn't have to add any zeros. All right, 2 times 3 gets us 6. We're going to add downward. 3 times negative 2 is negative 6. And this is our remainder, which means I'm going to cross it off. Ignore the remainder, right? So the y equals mx plus b, the line is going to be 2x minus 2. So remember, if you were to graph that, this last number is the y-intercept. So I would put a dot at negative 2. And this number is the slope. So the slope is really going to be up 2 over 1, right? So I'm going to go up 1, 2 over 1, up 1, 2 over 1, up 2 over 1. I'm just going to keep doing this. Okay. All right, or down 2 over 1, whatever. And I'm going to draw the line through it. I probably did that last one incorrectly because I didn't have a real grid there. Close enough to just make it a bigger dot. I'll move it. Here we go. Okay. All right. Now the thing about slants, it kind of divides you into quadrants. Like there's 4 pieces. You could either be here, that's one of the pieces, like here and here, that could be one option, or here and here could be another option. So in other words, you'll either be in the acute angles, both of them will be, or you'll be in the obtuse angles, both of them will be. It'll never be like one's in the acute angle and one's in the obtuse. So once I already have how this one looks, you know, let's say it looks like this. Just kind of guessing right now, right? This keeps going down. Then I already know that the other one has to be in the same region. It would have to look like this, okay? But there is something that we need to find out. Let's see if we cross the slant asymptote or not. Okay, so do we cross the asymptote? Let's ask that. Okay. Okay, so we're going to go ahead and set the original equation equal to the slant asymptote. Just make sure I copied everything down right from memory. Yep, okay. All right, so we would multiply both sides by the denominator to make the denominator go away. So that leaves us with 2x squared minus 8x plus 8. So remember how we said if you see something on both sides of the equal sign, that you can just cross it off because you would subtract it away. There's a 2x squared, there's a 2x squared. There's an 8x, there's an 8x, or negative 8x and a negative 8x. So we get 8 equals 6, but 8 does not equal 6. So this has no solution, which implies that it doesn't cross the slant. Okay. All right, so our guess at the graph is actually a pretty good guess at the graph. It's accurate. Now, if your online homework platform is requiring you to get more points, then you could plot more points. For me, on a test situation, I would accept this, okay? You just need to be in the general vicinity. But sometimes I've noticed it'll say something like, get 1 point on each side of the vertical asymptote. So we already have a point to the left of x equals 3. So maybe you could substitute in 4 to get a point to the right of x equals 3. But this would be good enough for me. Let's go check it out, see what it looks like. I'm just going to make this large because I think I remember. Okay. So we had 2x to the second minus 8x plus 8 divided by x minus 3. Now let's zoom out a little bit. Now what I'm going to do, zoom out a lot, huh? Let me stretch the x-axis a little bit so it's not so small. Let me type in our oblique asymptote. Our slant asymptote was y equals 2x minus 2. Ooh, that looks good. Look at the how they go out to infinity. Ooh, that's perfect, right? And then our vertical asymptote was x equals 3. And we set the denominator equal to 0. That's really good. Look at that. And we do cross at 2, 0 like we have in our graph. Okay. This looks really good. Okay, one more graphing one. So hopefully that's enough to kind of get the gist of what's going on here. Okay, here we go. So domain. So for the domain, you do need to factor both the top and the bottom, right? So I'm going to have to factor this. And I'm also going to have to factor this. All right. So the first thing I want to do to this one is take out a negative. Okay. And then I'm going to go ahead and do 2 times negative 15 to get negative 30. So we're looking for what multiplies to make negative 30 and adds to make 1. 6 times negative 5. That should do it. So we're going to have our negative sign, 2x squared. We're going to use the 6 and the negative 5 to rewrite the 1x. Slice this guy down the middle and use factoring by grouping from there. So I'm going to take out a 2x. I'm going to take out a negative 5, which will change the sign here. So the thing that shows up twice, that's going to be one of them. And the leftovers is the other. Great. So then that's the top. Let's go look at the denominator, right? Okay, so we're looking for factors of negative 12 that add up to negative 1. What would that be? Negative 4 and positive 3. So this is going to be x minus 4 and x plus 3. I didn't have to do the AC since the leading coefficient was 1. Okay, so our original equation would be this. Ooh, getting squished on here. Now notice something. We have a hole, right? When we set the denominator equal to 0, right? So when we set this equal to 0, This one is going to be a vertical asymptote. But this one, since this is the factor that canceled, this is going to be where our hole is, right? Okay, so we have a hole at. Now I'm just going to put almost, and this is what? Let's just take this negative and distribute it in, you guys, so I don't have to write that. So this is going to be negative 2x plus 5 over x minus 4. These aren't equivalent. They're off by 1 point, the whole. So I'll put that little approximately sign. We have to take the value x equals negative 3 and substitute it in here and here to figure out where the hole is. So we've got negative 2 times negative 3 plus 5 over negative 3 minus 4. So I substituted it in for all the x's. So this is going to get us 6 plus 5 over negative 7, 11 over negative 7. Okay, so let's put it all together. We have a vertical asymptote of x equals 4. And we have a hole at negative 3 comma negative 11 sevenths. Whoa, sorry, thought I was on the other function. All right, and then a hole at negative 11 sevenths. That's 1 and 4 sevenths. Negative 1 and 4 sevenths. Okay, so negative 3, negative 1 and 4 sevenths. So just a little bit past halfway. All right. Let me just stare at that for a bit and digest it. Cool, I'm already feeling crowded on this screen. So I am going to take all this stuff and go to the next slide with it. Oops, and I grabbed everything well, here we go, kind of have to. Okay. Okay. Delete out all this work so I have room. And I do want to keep our final answer there. Okay. Alrighty. So where are we at? We got the domain. I haven't been writing the domain. Let's take a moment to do that in case that's a question on your homework, right? So once you find out where the holes and the vertical asymptotes are, I won't do it for all of them, right? Then you have to exclude those. So like we said, negative 3 2/3 were excluded on this one. So you would go negative infinity all the way to negative 3 union, 3 all the way to 2/3 union, 2/3 all the way to infinity. Okay. It's hard to see it on this screen, but when you go to the next one, you can indeed see that that's the case, right? It's like negative infinity all the way up to negative 3, negative 3 all the way to 2/3, and then 2/3 all the way to infinity. Okay, so basically the holes and the asymptotes all get included, the vertical asymptotes, when you're getting that domain. Okay, so you have to exclude those values. So in this case that we're on, if we had to find the domain at this point, right? Let me just write it down on this slide because we have room. Both these are not on the graph. So you would say the smaller one first, negative 3 smaller, right? So negative infinity all the way to negative 3, negative 3 all the way to 4, and then 4 all the way to infinity would be your domain. We'll see that when we finish the graph, you guys. Just making sure that we had to do that on a problem, we would know how to do it. Okay. All right, so let's see here. We got the domain. So now we got to get x-intercepts. Let's do that. So in other words, we're going to put a 0 in right there, and we're only setting the top equal to 0. And I'm thinking, let's just set this top equal to 0. Remember, use the simplified version. So your math's going to be a lot easier. So let's see, And let's see, -5. And then we'll divide by -2. Cool. Okay, so we have an x-intercept of 5/2, comma, 0. 5/2 is 2.5, so about right there. All right, let's get our y-intercepts. So for our y-intercepts, we're going to let x be 0. In the original, that's the easiest spot because it'll annihilate this, annihilate that, annihilate this, annihilate that, and you'll just have the 15 over -12. So we would get 15 over -12, which if you divide by 3 to everybody, you would get 5/4, right? So it looks like 0, -5/4, or 0, -1 1/4. Let's see what that does. Okay, now we have to ask ourselves horizontal or slant, which one do we have, right? Let's go inspect those degrees. So we have the case of the degrees being equal. So if the degrees, well, board's glitching, huh? There we go, the words are back. We have an equal degree, then we just circle the leading coefficients, right? So in this case, it would be -2 over 1. So in other words, -2. So I'm gonna go ahead and put, and that's actually looking good with those dots. Fits nicely actually. But what I mean by that is this looks like this is probably what it's gonna be. At least to the left of the vertical asymptote, x equals 4. Okay. All right, so let's go ahead and go in now and figure out, do we cross the asymptote? So do we cross the horizontal asymptote, question mark? So we're going to set the simplified version equal to the asymptote to see if we cross it. So we would have to multiply both sides by x minus 4 in order to get rid of the denominators, right? And so that leaves us with, and I'm just gonna, I guess, bring it up here to give us some space. That gives us -2x plus 5 equaling -2x plus 8. Okay, there's a -2x on both sides of the equal sign, so we're just going to cross it off and we get 5 equals 8, which makes no sense, right? 5 does not equal 8. So since this equation has no solution, that implies we don't cross the horizontal asymptote. Okay. All right. All right, so then let's go plug in 5 and see what happens. Okay. We know either we're up here or we're down here. Since we don't cross the horizontal asymptote, we're stuck in one of those quadrants. So we're going to go ahead and plot points now. I think I can fit it on the screen. Such a easy function. I'm just going to try to. Meanwhile, what is this? Let me delete this thing out. Oops, that's the problem. I don't have one. Select on. Oh, darn. Okay, well, when I move it back, it should be okay. All right, so we're going to plot points. Sorry, you guys, that this is all squished onto one slide. There's just so much to do. Okay, so only one point that we have to substitute in, it's 5, right? So we're going to substitute in the point 5 into this simplified version right here, right? Okay, so if we substitute 5 in, let's just use the calculator because we don't have any space, right? Okay, so it's going to be -2 times 5 plus 5, and then over 5 minus 4, which is just 1. We didn't even have to do the bottom off. -5. Okay, so we get -5. So 5, -5. 5, -5 is right here. I have a good feeling now on how to, on how to make this happen. So it looks like, you guys, that we are going to look something like this. Okay. We have this hole over here at -3. Let's not forget that. Okay, so I'm going to put the original in case I made some boneheaded error, which I do all the time. And we have, what did we say, you guys? -2 for the horizontal and 4, was it? Oh yeah, that looks good. And we also said that we had discontinuity at -3, which is like right here. Ah, we have a hole there. This looks so good when compared with what we ended up saying, right? Look at that. That looks really good. Okay, so kind of shocking that as much faking as we're doing, that we're like really accurate. It comes down to just getting key pieces, getting those asymptotes, right? Seeing if you cross the asymptote, getting the x and y intercepts, and then also finding if there's any holes on the graph. Okay. All right. So we're going to end with the word problem. If you have kids, you've actually thought about this before. You're like, your kid's sick, it's late at night, you don't want to go out. All you have is the adult medication. Like, how much of this should I give my kid? You know, like, so I'm sure you've estimated, you're like, this seems about right. Yeah. So there's actually this Young's rule. So it says it's a formula for calculating the approximate dosage for a child given the adult dosage. Okay, so the adult dosage is going to be D. I always like to make sure I know what my variables stand for. Adult dosage is D. Child's dosage is C. And X is the child's age in years from 2 to 13. So it says, what's the horizontal asymptote? Well, if we look at our degrees, they're both degree 1. That means that they're equal degree, right? So that means that we just need to make a fraction out of the leading coefficients. So it looks like it's going to be D over 1. Or in other words, just y equals D. Okay. I'll come back to what this means in the context of the problem after maybe we've kind of sketched a graph, okay? So we know that y equals D is where we have our horizontal asymptote. Let's go get our vertical asymptote. So x plus 12, we're going to set it equal to 0. It's not a hole because it doesn't cancel with the top. So -12, we'll just pretend that this is -12 over here. That's going to be where our vertical asymptote is. Okay. All right. And so I'm just going to tell you that the graph looks like this. And then if we substitute something in past like -13, it'll be positive. So the other part of the graph would end up being up here. But what I want you to notice is this is from 2 to 13. So on the x-axis, let's say 2's right here, and let's say 13's right here. This is really the only portion of the graph that we are going to be looking at. The rest of it is bogus and doesn't make any sense. I mean, think about it. Over here, you're having negative ages for the kids because remember, X is the child's age. So it's like negative ages. That doesn't even make sense. So this is the only portion where this Young's rule applies, right? Okay, so I'm not even going to worry about that other piece of the graph because that's utter nonsense in this case. Okay, so let's go back to part A. The vertical or horizontal asymptote was D. Well, what does D stand for? D is the adult dosage. So what's happening here on this graph is we are getting closer and closer to the adult dosage as the child gets older. Okay, so when it says, what does it mean in the context of the problem? As the child gets older, their dosage will approach the adult dosage. All right. For an adult dosage of 50, so that's going to be D. What is the approximate dosage of a 9-year-old? So that's going to be X. So we're just going to substitute 9 in for X and 50 in for D. So C of 9, the child's dosage if they're 9, is 450 over 21. Let me get that on a calculator. So 450 divided by 21, I am getting 21 point. It says this, which is kind of interesting, that this repeats this many digits because it has a bar over it. So that's interesting. I'm just going to round down because in reality, if I was like trying to get this dosage, you know, and I have like one of those little injector things or like a cup, I'm like 21 sounds good, right? I don't want to round up because I don't want to overdose my kid. So I think 21, what are we measuring with here? Milligrams? 21 milligrams would be the dosage for a 9-year-old. Okay. All right, you guys. So hopefully you could see, it was neat to see like why we would care about a horizontal asymptote. And there's actually lots of situations where the x-axis is time and we want to go, well, if this trend continued out towards infinity, right, as time grew, where would we head? You know, that's a really important question for a lot of things like population, stuff like that. Okay. And then hopefully you, on these graph ones, kind of found a rhythm. I mean, each one of them has its own little unique thing that can kind of throw you off. But just make sure that you're getting those basic things and that you have those rules down. I told you guys to flashcard yourself, like, do I know how to get vertical asymptotes? Do I know how to get horizontal? Do I know how to get slant? So at least you're not thinking about that stuff as you're going in and doing these. All right, you guys. Well, thank you for joining me. Take care.